Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Coders, welcome back. Step 35. I'm gonna try a little bit of a different approach this time because there's so many changes, and if I go through all of them, some of them are really small and insignificant, some are a little bit bigger but still not very significant, and it's just gonna drag the video on very long. So there's a couple of things that are really apparent in this version. We have a new enemy, which is a spider, and the spider can walk left or right, but we want it to be able to jump. So when it's walking over characters that are blocking him from falling down and there's a gap, we want him to jump over, right? Or at least initiate a jump so he can jump off if the gap is large enough, or he just jumps over and lands on the platform that is to the left or to the right. So this is a new sprite, and that comes with all the sprite data, and it comes with all the tables have to be updated. So I won't show you that because I've shown that a couple of times already, and it's basically all the same. There's a new behavior function. There's a new hit behavior function, so we have to look at those. Also, what is new is that the mummy, before, if he was turned towards you, he would run, basically take 2 steps every frame instead of just 1. Now we have a hit behavior that is hurt and turn. So basically when you hit it, he turns towards you, and then the rest of the code makes him run. So all we have to do is make him turn around as soon as he's hit. So that's a change of the hit behavior. So that's what we're looking at. I'm going to show it to you first, what it looks like in game, and then we'll look at the code. And along the way, perhaps I'll mention some other things, like there's some code that was specific to the player control that's been moved out and made into a subroutine that you can call. So that's basically the same code but in a different place. So I'm not going to show that because that would just drag things on too long, and the code's already been mentioned. So let's look at what the changes look like. There's a new level, level number 9, which looks like this, and this is our spider. And as you can see, it basically walks left and right, and when it is blocked on the left and the right, it will just reverse its direction, and it is jumping over holes. Now, where I'm standing now is 3 characters wide. This is where I'm standing now is just 1 character wide, but it's jumping over those gaps. Now, I'm going to shoot this spider, and you can see that it's changed color. So that is another change in this version, that when an enemy is annoyed, you can give it a color. Also, you can see that no item appeared there. That was a bug in the last version that's been fixed. I'll come to that. It was just a stupid bug. What we want is when you destroy an enemy, that it will randomly create an item to pick up. Now look at what happens. The zombie is walking around. If it turns and sees me, we'll have it do that. You know, zombies walk slowly, but when it turns and sees me, it'll run. Woo! And then when it doesn't see me, it'll stop. So, but what happens now when I hit it? Boom! It'll start running toward me, and I got killed by the bat. But when I hit it, bang! It immediately turns and runs towards me. So that's the hit and turn behavior. It got me. So that's a couple of things that we are going to look at, and let's do that now. Of course, there is the new sprite data. You saw that the new sprite has 3 different shapes. One with his left leg up, one with his right leg up, and one just standing, and he just goes through those. If we look at the code, I'm going to scroll to the bottom where all the, let's see, where is that? All right, this is the behavior table. You can see we have a behavior spider function now. And also if we go to the hit tables, we have a hit behavior hurt and a hit behavior hurt turn. So the hurt turn is new. We'll look at that, and the behavior spider is the first one, of course, that we'll be that we're looking at. So let's go to that behavior spider. So what we want to happen is that if we are not already jumping and not already falling, we just want the object to walk right or walk left. In this case, we're moving right. Otherwise, whatever is happening, jumping or falling, that is already being taken care of. So all we need to do is detect whether or not we have to start jumping and initiate that jump. Then on the next frame, the code will detect, oh, we're jumping, and it will just finish the jump for us. So, and this is actually quite an elegant way of detecting that. Right, we're loading the sprite's jump position, which always has a value if we're in a jump, and we are ORing that with the detection of whether or not we are falling, which is set to 1 when we are falling. So, and this is the typical behavior that you want from an OR instruction. So if we're jumping or falling, then we have a value and we only have to move right. This, by the way, makes it possible that for us to be jumping and moving right or left. Otherwise, we'd just be going up and down. So, but we're now interested in the other case. I know it gets complicated, but that's programming. So we are not jumping, we are not falling, and we are going to walk right. Just imagine that this block of code exists twice, once for going left, once for going right. So we're just looking for the right side of things. Now, we're going to go to this function, see what it looks like. So we're going to walk the object right. If it could fall off, we jump. If we're blocked, we turn. So we change the direction. Now, and this is quite tricky, but you have to remember that the sprite can move in pixels. So there are 8 pixels, 0 to 7, and that is the size of one character. And every sprite also has a character position on the screen. So this delta means that we are halfway through a character somewhere. So we can only start jumping if we're flush with the next character, right? So we have to be the delta needs to be 0. So we basically load our x delta, so our horizontal delta. If that is 0, then we are flush, and we go to check can move right, right? So that's down. That's down here. If we are not flush yet, and we are going right, then just increase our delta position. We load the position again. We compare it to 8, which would mean that it is now that it is flush. But we compare it to 8. If it's not 8, then we don't do a character step, which is this. We just move the sprite right, which means it'll just move the sprite right one position because there's nothing going on. We're not flush. We just moved it right. If we are flush by this time, then we set the delta position to 0, and we increase our character position, which means we've just moved to the next character and we're flush with the border. And then you move the sprite right. That's all just handling moving between characters, right? Now, next frame update, suddenly we're flush, right? Now, we come to a point where we have to check whether there's a hole in front of our feet. So we jump to check can move right. That is this function. Now, this function is sort of an overview function. It calls another subroutine, can walk or jump right, which does the actual character checking, which we'll look in next. And that can return a couple of values. Either 0, which means that it is blocked, which means that it can't fall and it doesn't have to jump. So blocked means just return us. Bang. Nothing's happened. We're just walking on. If that function can walk or jump right returns 1, then we can move right. Now, can move right is just this function again. So we are not blocked and we are increasing our delta position. Which means as much as there is no hole and we are not blocked on that side. Now, in the other case, we get 2, there is a hole and we have to start jumping. So we load our jump position. If we are not already jumping, this function has checked for us that there is a hole. You know, it's returned the number 2, which we'll look at in a minute. And we have to start jumping. So what we have to do now is we have to initiate a jump. Now, most of the time, I mean, we have to do a check here. If we're going to initiate a jump, we have to check, but it's more like a sanity check. We have to check whether or not we are already jumping. So we load our jump position. If it's not equal to 0, then we have to move to can move right. But most of the time, we will not already be jumping when we're here in the code. So we'll just end up here and we'll move our sprite jump position to 1 and then go to jump can move right. Okay, so this is initiating the jump when this function says, okay, we've come up to a hole, we're moving right, and we have to start jumping. So all we do here is initiate the jump, we jump to can move right, we do the right move, and then we move the sprite right and we jump out. Now, the big question is, how does this function work? How does it check what is to our right? So we go to the declaration again. Right. Can walk or jump right. I've made a little schematic because otherwise it can get confusing. Imagine this to be the characters, right? Our player character is 2 characters high. So suppose we were standing right here. These gray blocks are characters that are blocking our fall, and this is actually a hole. So this is not blocking our fall, and none of these are blocking either. It's just empty, non-blocking characters. Now, So when we're standing here and we want to determine whether or not we can move in that direction and to the right, we have to check whether, and I'll mark them yellow if I can, we have to check whether this one, oh, it's turned gray. This is Microsoft Paint. I indicate yellow and it paints gray. I don't know why that's happening with the, oh, it's a right click, sorry, call it color 2. So these, I have to check these 3. I want to check, in order to be able to walk or jump to the right, these 2 yellow ones have to be non-blocking characters. And this one, this red one, should be not blocking my fall. So not blocking and not blocking my fall can be 2 different things, right? This can be a breakable block or whatever. So I have to do these 3 checks. Now let's look at the code. We take our own Y position, our own character Y position. And that is like this. I'll make it orange to make it even more confusing. This is us, right? And our Y position is this one. Now, we decrease Y, which means that we go to our head, right? The line that is representing our head. We load the 0 page pointer with the first character on that line, and then we add our own X position so that we're at the exact X position of where we're standing. But that's not where we want to check, because we want to check the character to the right of that, because this is our head and we want to be checking that one. So we increase this and then we load the character that is there. We check if it's blocking. If it is, we say blocked right and we end. If it isn't, we transfer the current value of the Y register, which was this position, to the accumulator. We clear the character and add 40. 40 being the number of characters on one line. So if we add 40, we end up here at our feet, right? Not at our feet, but one position to the right. So we add 40, and then we transfer the accumulator back to Y. Why do we do that? Because we can't add in the Y register. And then we check the character that is there. Is that blocking? If it is, then we can't walk or jump right, and we're blocked. Otherwise, we want to check if there is a hole in front of us. Now, the hole is one lower still. So it's below our feet and one to the right. So here we go. We load, again, our own Y position. We increase Y now because we want to go one line lower. We get the position of, we load the 0 page pointer with the first character of that line. We add our X position, adding 1 because we want to go to the hole, right? We take the character that is there, and now we check whether or not that character is blocking our fall. If it's not equal, then there is no hole. It returns 1. And otherwise it returns 2. So basically it looks kind of complicated, but with this schematic, this is us and this is the floor and this is the hole and these are non-blocking characters. It kind of makes sense of what you have to do. You have to check 3 different positions. Now there is one tiny difference between the 2 directions here. This is the object walk or jump left. And let me see. Yeah. This is the object walk or jump right. And there's a difference. There's a tiny difference. And it took me a little while to figure out why that difference exists. And I'll try and explain why or what the difference is. You can see that the 2 routines are not the same. Object walk or jump right has to do an extra step, an extra check. Let's go to the left side first, because that one's simpler. Object walker jump left. You load your X position, your X position delta. So that's basically your pixel position between two characters. And you check if that is 0. Now, walking left is equal to decreasing that value, and it goes from basically from 7 to 0. And if that is 0, you jump out. So by the time you reach this code, you know that this value is not 0. It can be 1 at least. You know, at its smallest version, can only be 1. And then you move the sprite left, and below there is a walk left bit. And what you do here is you set, or basically you reset the delta to 8, and you store that in the delta value for that sprite. Then you decrease the actual character position because you've walked left and you've crossed over to the next character, and then you jump to can move left, which is back up here. You decrease that delta value to 7 and you move the sprite left. So that is different from, and there we go, the object walk or jump right, because that does loading of that delta value. You check if it is flush, if it is 0, but now you're moving right? So when you come to this place, it's you're not able to tell whether you're flush on the right side of the character, because that it only happens when the delta has become 8 at this point, right? So this code needs to be different. So you increase the X delta, you load it, you check it for being 8, and if it's not 8, then you don't have to do a character step, meaning going to the next character position. If it is 8, you have to reset it back to 0 and then increase your X position and then actually move the sprite right. So I said before that these functions were the same, that the code for going left and right was the same. Well, it's not. There's a tiny difference, and that has everything to do with moving slowly towards the right is different than moving slowly towards the left, because checking for 0 is easier in assembly than checking for 8, basically. Now all that we need to look at is the hurt behavior. This is hit behavior hurt. Basically, we for the sprite indicated by X, we increase its annoyed level. We load from the sprite active table, again indexed by X, and you get the sprite type as we know. And from that type, you can use the type as an index into this table, which is indicated by the word type here, to look up its annoyed color. So the color it gets when it is annoyed. In other words, when it is hit. And these functions are assigned to each sprite type as we in the table that defines the hit behavior for every enemy type. So the accumulator contains the color that we've set for this enemy type, and then basically we just set the main color for that sprite to that value and we jump out. So what happens is that you hit the enemy. At that moment, the enemy's hit behavior is executed, which is this function. Look up the enemy type, look up the color, set the color, and we're done. So basically we hit it and it changes color. Now there's also the hit, behavior, hurt, and turn. So remember that the mummy, now when you hit it, it changes color and it turns towards you. So this function, we've already looked at that in an earlier video, looking at player, which basically determines the enemy's position relative to the player's position, and looks at their direction and tells whether or not the enemy is looking at the player. If the enemy is already seeing the player, we jump to already seeing the player, which means we increase the sprite annoyed value again. And basically it does the same color trick as before, but if we're not seeing the player, we get to this code. So all we have to do is change the enemy's direction. Now 0 is going right and 1 is going left, I believe. So you know, off the top of my head, basically for the sprite indicated, we take its direction, we exclusive OR it with 1. Now we're only interested in the least significant bit, and an exclusive OR with 1 just flips the bit. If it's 0, it turns 1. If it's 1, it turns 0. And we store the result of that in the sprite direction. So this basically turns every 1 into a 0, 0 into a 1, changing the direction. And then the sprite gets annoyed. And further on in the mummy's behavior, we get like 2 sprite moves instead of 1 that we've already seen in other videos as well. So basically all we have to do is determine whether or not we're looking at the player and change the direction accordingly. What I wanted to do is go to the bottom of the code and show you this table. Where are we? Right, well, the spider animation table. You've seen that. The type annoyed color. This table indexed by type, and these are all color values that can be set directly into the VIC for each sprite. So that's the table that we use for that. So I think I've gone on long enough. I've shown you all the things that are changed. Again, some code has been moved in the has been turned into a subroutine. I won't show that. It's just the same code, but it looks different. Some code has been reshuffled, moved to a different place. Nothing functional changed there. So I hope you enjoyed this one. Thanks for watching, and I'll see you next time. Bye-bye.